Hopefully you remember from our last discussion that graphing linear equations are a lot of fun and can be really easily done when they are written in this slope-intercept form, y equals mx plus b. Please recall that it's called slope-intercept form because m represents the slope of the line and b represents the y-intercept, the location on the y-axis where the line will cross. So just as a short example here, if we're looking at y equals 2/3 x minus 5, then I know that I can start graphing the equation by locating the y-intercept along the y number line of -5 and finding the next point by rising 2 and running 3, because the slope here is 2/3 and slope is the rise over the run. So I'll rise 2 and run 3. Now only 2 points are needed to determine a line, but I can find many points that are on this line simply by continuing to rise 2 and run 3. Ooh, that was a lot of fun. There are two special types of linear equations that we're going to talk about here today that are kind of disguised sometimes. They don't necessarily look like they can be written in this slope-intercept form. A lot of people make them out to be a lot harder than they should be. And they are horizontal lines and vertical lines. I'm going to go ahead and tell you right now that vertical lines are always written in the form of x equals some constant. So we'll give you an example here, x equals 4. And horizontal lines are always written as y equals some constant. And the example we use today is y equals -3. But I want to look at the reasons why. Why are horizontal lines written as y equals some constant and vertical lines written as x equals some constant? Let's examine a horizontal line first. Let's look here at y equals -3. As you can see, it goes through the y-intercept of -3, but notice that every point that's on this line also has a y-coordinate of -3. So here, if I look at the point 4, -3, or -5, -3, they will all have a y-coordinate of -3, which is one reason why we call this equation y equals -3. Because no matter what the x value is, y will always equal -3. Another reason for justifying why we're going to call this equation y equals -3 is because think about the slope in the y-intercept here. Obviously the y-intercept is -3. But what about the slope of this line? If I choose any 2 points on this line to determine the slope, look at what happens when you calculate that. If I want to find the change in y divided by the change in x, any point that I choose, the change in y is going to be -3 minus a -3. Let's just choose these 2 points here. And in the denominator here, the difference between the x values will be -5 minus 0. Don't forget that subtracting a negative is the same as adding a positive, so we will always end up with 0 divided by some constant, meaning that our slope will always be 0. So when I go to write this linear equation in y equals mx plus b form, I know that my slope is 0 and my y-intercept is -3. Well, since 0 times anything is 0, then I can just simplify this equation to read y equals -3. Let's take a moment to look now at the vertical line. Vertical lines are a little bit more tricky. But just like with the horizontal line, we can use the same justification that every point on here is going to have an x-coordinate of 4. So even if I choose 4, -2, or 4, 5, every single point on this vertical line is going to have an x-coordinate of 4. X will always equal 4, no matter what y equals, which is one reason why we can say the equation for this line can be written x equals 4. Don't fall asleep yet. Still got more to show you. Remember that I said that the y-intercept form is really easy. Think about what the slope and the y-intercept are here. Well, at first look, you'll see there is no y-intercept. Uh-oh, this line never crosses the y-axis. Can I write it in slope-intercept form if it doesn't cross the y-axis? Oh. Well, what about the slope? Let's think for a moment about what the slope is. I'm going to choose 2 points on here. Let's say 4, 5, and 4, 0. When I go to find the rate of change, the difference in the y values is 5 minus 0. And the difference in the x values is 4 minus 4, leaving us with a rate of change of 5 over 0. Uh-oh, we can't divide by 0. Oh no, our slope then has to be an undefined slope. So it cannot meet this criteria at all if it's a vertical line. It has an undefined slope, it has no y-intercept. We cannot write it in the slope-intercept form. So we've written it in this form, x equals 4. Logically, every single point on this line has an x-coordinate of 4. So no matter what I plug in for y, since there is no y in this equation, x will always equal 4. So there you have it. Horizontal and vertical lines. Sometimes can cause you a lot of trouble, a lot of sleepless nights, but they're really a lot easier than a lot of people make them out to be.